Good morning, students. It looks like we're doing Lesson 8 in Unit 4 today. This is on page 185 in your student workbooks. We're going to be interpreting and creating graphs. Grab that highlighter and highlight. Let's sketch some graphs to represent some situations. We begin with a warm-up which says which one doesn't belong. Discuss with your table mates over temperature over time which of these graphs doesn't belong and why. Remember, there's always a reason to explain why each one does not belong, so challenge yourself to try to get one for each. Okay, how'd you do? Let's take a quick peek. So here, what could you say about why this one doesn't belong? All right, you could say it's constant, never goes up or down, zero slope. You could say no min or no max. Any of these things would work for why you said this one does not belong. Okay, how about this next one? This is the only one that goes up and goes down. This is the only one with one maximum. Think of all the things you could say about why this one doesn't belong and put it in your own words. How about this one? Goes down and then up, has a minimum. This one starts going up, then down, then up, then down. And so it has two maximums, 1, 2, 3 minimums. This curve keeps repeating this pattern. So there's a lot we could say about that one being different. So each of these has a reason. Whatever your group mate said, you could have said a different one with your reason. Make sure you have something written down, please, on the warm-up. Here we're talking about flag raising. Here are some graphs that could be a possible representation of the function. And down here it's saying for each graph, explain what it tells us about the flag. Decide as a group which graph appears to be the most realistic and which one is the least. So here, the flag begins at 0, so on the ground, and then is raised at a constant rate over an interval of 5. We don't know if this is 5 seconds, 5 minutes. We don't know if the height is in feet or meters. So we'll just say that. The flag is at 3 to start and stays there. So it doesn't get raised at all, it just stays at the same height. For this one, the flag starts on the ground, is raised up to 2, then pauses for a bit, and then continues to be raised. Here the flag starts on the ground, is raised up 2, then back down to the ground, then up again, and so on. This keeps repeating. So down, up, down, up, down, up. Look at that little graph. Okay, this one, the flag is raised and then pauses, and raised, then pauses, raised more, and pauses until it gets all the way to the top. This one, this flag starts on the ground, is raised up at a constant rate, then dropped at a constant rate where it stays part way up. So whatever your own words to explain each of those is, something along these lines, you're then going to say which of these appear to be more realistic or least realistic. So just starting on the ground and raising it up, I think that kind of makes sense. Having it at 3 and keeping it at 3, well, what if it was at half mast for some sort of a tragedy, and they're honoring that tragedy, so I guess it could stay at 3. Going up, staying partway, and then going up the rest, going up, down, up, down, up, down. It's almost like maybe the person that's putting the flag up is having some sort of an issue, right? I don't think that one's very realistic. Going up, staying, going up, staying, going up, staying. Maybe you're pausing while you pull the string again. No, I still don't think that one's very realistic. Going up and then going down in half mast. That could be an example of when you need to go to half mast. So whichever one you agree on, you're going to say something like, I think graph A is most realistic because, or I think graph B is most realistic because, I think graph C. So choose yours with your group and then explain your reasons why. Here's another graph that relates time and height. Can this graph represent the time of the flag and explain our reasoning? Well, if the time is 3 seconds, the flag can't be at the ground and up at 6 at the same time. So this cannot represent the time and height because the flag cannot be at different heights at the same time. Is this the graph of a function? No. This graph has multiple outputs for the input of 3. So this is not a function. All right, finally, we're going to go ahead and search up a video of a flag being raised, and then I want you to sketch a graph that could represent that function. And so if you go look on the assignment, there is a link to watching this flag get raised. So label your axis time, label your axis height, pause the video and go try to sketch this out. Use your graph to estimate the average rate of change from the time it starts moving to the time it stops. And so a possible student response might look like this. All right, go ahead and look at that and see how that looks compared to what you did. To prepare for a backyard party, a parent uses two identical hoses to fill a small pool that is 15 inches deep and a large pool that is 27 inches deep. The height of the water in each pool is a function of time since the water is turned on. Here are the descriptions of three situations. For each situation, sketch the graphs of the two functions on the same coordinate. And so, situation one, each hose fills one pool at a time at a constant rate. When the small pool is full, the water in the hose is shut off. The hose keeps filling the larger pool until full. Situation two, each hose fills one pool at a constant rate. When the small pool is full, both hoses are shut off. Situation three, each hose fills one pool at a constant rate. When the small pool is full, both hoses are used to fill the large. So for this one, notice how you're doing two separate things on one graph. All right, see how you did on sketching out your situations compared to these sample responses. Finally, there's going to be one more link for a video for a tennis ball being dropped. Here are the still images of the situation. The height of the ball is a function of time. Suppose the height h in feet and t seconds after the ball is dropped. Use the blank coordinate plane to sketch a graph of the height of the tennis ball as a function of time. To help you get started, here are some pictures. So at 0 seconds, it's 1.03, 0.28, it's at 1.48. So you're picturing like here, down, bounce, up, here, bounce, up, etc. And so here we gave you these inputs. Go ahead and fill in the outputs from those pictures and then sketch your graph of the bounce. Identify the horizontal and vertical intercepts of the graph. What do you think those would represent? Well, the horizontal intercepts would be when the ball touches the ground. So at what spots did it touch the ground? Like right here and right here. So that's at 0.54 seconds. What are the vertical intercepts of the graph? That's when the ball is starting before it gets dropped. So here, before it gets dropped. And you're going to put that up there as a vertical intercept. Explain what the coordinates tell about this tennis ball and find the maximum and minimum values of the function. Explain what they tell us about the tennis ball. And then you're going to go highlight the summary as usual, read through what we were supposed to learn from today. So what's a sample student response for this one? All right. Okay, there's the sample responses for number 2 and number 3. How'd you do?